Let f is a function defined from r squared to r given by this structure. Then we need to find partial derivative with respect to x of del f upon del y minus partial derivative with respect to y of del f upon del x at the point 0, 0. Now first understand the meaning of partial derivative. As first partial derivative of del f upon del y, it can be written as partial derivative with respect to x f y. Now what is the meaning of fy? Suppose this is input and we need to find derivative with respect to y. Then limit, as suppose h for x and k for y. K for y means increment, or suppose we are choosing these h and k such that we are going to approach a specific point. As we are going to find fy, so I am taking k tends to 0, limit of f of, and at a point ab, so a comma b plus k minus f of ab divided by k as k tends to 0. This is the meaning of partial of f with respect to y at the point ab. But we need to find partial with respect to x of this one. So partial f with respect to x at the point ab can be written as limit h tends to 0 f of a plus h comma b minus value at the point fab and h divided by h. Now come to the point as equation 1, partial x of partial f with respect to y will be, this is input function, and we need to find at the point 0, 0. So input at the point, and input is fy at the point 0, and we are taking partial derivative with respect to x, so change in x, so 0 plus h comma 0 minus function at that point, function or input function is fy, and it is at 0, 0 divided by h, and h tends to 0. Now let us suppose this is equation 2, and we need to calculate this impression. First fy at 0 plus h comma 0, this will be fy h comma 0. H comma 0 is the point where we need to calculate partial derivative of f with respect to y, and it will be limit k tends to 0, because with respect to y, so whenever I take a derivative with respect to y, I choose change k. If with respect to x, then h. So function is f at that point h comma 0, and change y coordinate with this k minus f at the point h comma 0 divided by k. This equal to limit k tends to 0 f of hk minus f of h comma 0 divided by k. Now function f xy given by x square y x minus y divided by x square plus y square when xy is not equal to 0 0 or origin. So hk will be this one. So limit k tends to 0 h square k h minus k divided by h square plus k square, and this is k. This is k coming from here. So limit k tends to 0 and this k cancel out by this one h square h minus k divided by h square plus k square. When k tends to 0, when k tends to 0, value of this one will be h cube divided by h square equal to h. Now put this value in here, so it can be written as this is h minus and fy 0 0. We will calculate fy 0 0 divided by h. This is the limit h tends to 0. Now call this equation 2. We need to calculate fy at 0 0. So fy at 0 0 will equal to limit k tends to 0 function value at 0 0 and change in y coordinate. So 0 plus k minus f of 0 0 divided by k. As x coordinate is 0, so f is x square y and x minus y divided by x square plus y square. X coordinate is 0, so value of this one or all function value will be 0. So 0 minus 0 divided by k and limit k tends to 0. So this value is 0. Now put this value in equation 2. If you put this value in equation 2, it will be limit h tends to 0 h minus 0 divided by h equal to h upon h equal to 1. So value of we need in first, as you can see, this value is 1. Now we need to calculate value of this one. So partial derivative with respect to y of partial f with respect to x. This can be written as fx. So it will be del f del upon del y of fx at the point 0 0. This will equal to limit k tends to 0 because with respect to y. K tends, you can take h here also, but remember the coordinate, either change in x or change in y. So we will take change with respect to y. Fx 0 0 plus k minus f of 0 0 divided by k, and this one equal to limit k tends to 0 fx 0 comma k minus f of 0 0 divided by k. Now call this is equation 2. So we need to calculate fx 0k, and this means that limit h tends to 0. Why? Because we are taking derivative with respect to x. Well, f at the point 0 plus h comma k minus f of at that point divided by h, and this one equal to limit h tends to 0 f of h comma k minus f of 0 comma k divided by h. As x coordinate is 0, by the defining property or defining structure of f, this value will be 0, so it can be written as limit h tends to 0 f of h comma k minus 0 divided by h, and this one equal to limit h tends to 0, this is h square k within bracket h comma h minus k divided by h square plus k square, and this is h. Now one power cancel out by this one, so this equal to limit h tends to 0 h k h minus k within bracket divided by h square plus k square. As h tends to 0, as h tends to 0, the value of this one is 0 upon 0 plus k, and this one equal to 0. Check once again, hk within bracket h minus k, okay, it is fine. Now put this value in equation 2, so this value is 0, so limit from this point, limit k tends to 0, this value is 0 minus f0 comma 0 is 0, and k, and this value is 0. So put these value in original equation, as we need to put or find the value of partial with respect to x f of fy minus partial with respect to y fx. This value I got 1 minus 0, so value is equal to 1. You can check in this one, we get the value 1